All right, hey, there we go. Welcome to Postgres. The clock's not ticking. Okay, the clock is ticking. All right, and I'll try to talk into the mic. So, hello, everybody. Easy for me to say. Hi, everybody. Hope everyone's having a good time so far. Day one was good. Yep. All right. Awesome.
Come on, people.
All right. So, quick question in the audience: how many of you? So, I assume everybody here uses Postgres on some level. You're familiar with it, hopefully. Postgres SQL. Sorry, forgot. You're from California. You pronounce it differently. Okay. So, how many of you used some other database before you started using Postgres? Yeah, so that's like just about everybody, right? Like Postgres is never everybody's first database. There's a lot of other databases out there. You've probably heard of some of these, like Oracle, SQL Server. You have like MySQL, MongoDB. So some of these, yes, you may not feel they're actual databases. But there's one thing that these other databases do all have in common that Postgres does not actually have. And that is actually money. Right, so like you have Oracle, who's like one of the largest software companies in the world. SQL Server is by Microsoft, again, really huge. MySQL was bought for like $1 billion or something like that.
Which
so
is now part of the first line.
yeah, exactly. It's part of the first line and going an offshoot. And even like MongoDB got like 100 million in funding, right? So that allows them to go out and spread the word about their database software, right? And tell people about it and show them how to use it and make all that work. And what Postgres doesn't have, as far as I know, and I've checked in a lot of pockets within the Postgres community, it doesn't have like hundreds of millions of dollars like lying around to do this. So how do we do this? We do it through Postgres advocacy, right? There's a ragtag group of people who've been kind of championing Postgres for many, many years, and that brings us to PostgreSQL.us. Yay! So what is Postgres US? We are a nonprofit in the US, and we focus on Postgres advocacy within the US. There are other groups in other parts of the world that do this. There's one in Japan, there's one in Europe, I think. Still one in Europe? Yep. Okay, so there's one in Europe. Yeah, more than one, in fact. And there's an international group that also works. But in the US, we have PostgreSQL US. I happen to be the president of PostgreSQL US, which is why they made me come up here and tell you about it. But I'm happy to tell you about it because I want people to know if you're trying to figure out a way, hey, can I get involved? Can I do stuff with Postgres? This is definitely an option that we'd like you to consider. What do we actually do? The main thing we do at the most is we try to help people who are doing local meetup groups. Like we'll either fund them, like pay for their meetup, or help give them pizza money, or arrange speakers or whatever, give them advice on that. So that's one of the big things that we do at the moment. We also do sponsor conferences and help conferences run. We'll occasionally send people to conferences to talk about Postgres. We like to do that usually at non-Postgres conferences. So like if there's a Linux Fest in your area and you want to go talk about Postgres, we can help you with that financially if you need to, or run a booth at a conference. We'll help you with that. Basically items around education and advocacy, right? Telling people about Postgres, why they might want to use Postgres, how it's the best thing ever. And all that kind of stuff, right? That's what we're all involved about. And we don't have huge amounts of money that are flowing into us, but we have some money, and so we try to figure out how best to use that, right? We're totally volunteer driven, right? It's not like paid positions or anything, but if you're interested in Postgres and want to get the word out, you can totally help. In those different activities that we do, we certainly need people who can help out, and we pretty much only need you. You don't have to have like deep skill in C, right, or understand like how to code MVCC and written like 3 implementations of it. Like, if you know how to do that, go spend your time hacking the Postgres backend, and we're comfortable with that. But if you don't have those skills and you're worried, like I don't know that I could contribute to Postgres, it's very deep and technical, and maybe not. Some of us are not super deep and technical, so you can help with this type of mission of doing the advocacy and talking to people and helping out with those things. One thing in particular, we just passed a resolution that we're planning for next year is to do diversity scholarships, and they're going to help sort of within the Postgres community. We're putting together a panel for that if that's a topic you're interested in or you've studied and researched. We certainly are looking for input because we want to make sure that rolls out well, and sort of help the Postgres community, certainly within the US and elsewhere. So once again, United States PostgreSQL Association, PostgreSQL US is the website. We need all kinds of volunteers, web people as well. I will note that the registration is currently broken on the site. So see, we really do need volunteers to come and help us. But feel free to like find me at the bar or whatever, or the after bar or the bar after that, and talk to me if you want, and I'll be happy to like try to get you involved and get things going. So that's it for me. 12 seconds to spare. I don't know what more you want.
Okay, so hi everyone, I'm Magnus Hagender. And I figured I'd tell you a short story. The reason for that is that it's a lightning talk, so it can't really be a long story. Some of you may have spotted this on Twitter yesterday by Gabrielle, sitting right here. They know something about, we have X left on the bar tab. Well, it's not a problem. Magnus is on his way. And the reason for that is obviously I got here late. I only got here last night. And the question is why, right? And that's the story. So to do that story, we're going to start somewhere far away. This is not Dallas, as you may have expected. I'm out of Stockholm in Sweden myself. This is not that. This is actually stolen from my manager's Facebook page. I claim that that's what she was doing when the rest of us were working. And it's sort of like places like this. Has anyone figured out where this is yet? Nobody yet? Okay. How about this obvious hint? Yes, that's a polar bear. Actually, yes, these pictures are from Tromsø. That is Svalbard. That is the warning sign that polar bears may be everywhere on this island. It's Norway, right? It's northern Norway. Or Norway in general. I'm sure for most of you, when you think Norway, you think something like this. It's like it's all Vikings and stuff like that. That's basically the ruler of Norway, right? We can all sort of assume that. Actually, that's not it, which brings us to the more thing. This is actually more like Norway now. This is, I had to make these slides in a rapid move. These are all the different counties in Norway. And their old names and their new names. I'm not going to make you learn them all in Norwegian. I could, but, this is not Norway Open, is it, right? I think it's Postgres Open, but it's not that much difference. But it's still that. So, and this talk was voting Postgres. So let's bring those together. In Norway, it's actually a democracy now. It's not a Viking king anymore. I think they changed that like a couple of weeks ago. And they actually held elections this week for county and municipal parliaments. It's approximately 4 million voters in Norway, and they get an average turnout of about 60%. So yes, they're actually smaller than Texas. If I look at it, they're about the same size as the Dallas metro area. But I don't think they have 4 million eligible voters in Dallas. That's 4 million people in total. It's like 4.2 million there and 4.06 million voters in Norway or something. But it's approximately that size. It's not the most populous country on the planet. And they do a lot of interesting things in their voting. They have pre-voting that everything does, but the main thing that they have is obviously an election day. It was this Monday. Open, as most things, it opens at 8 a.m., it closes at 9 p.m. They actually use paper ballots. They've tried e-voting, it didn't work. They've not gone down the road of machines, because we all know how well that works. And the deal is these are all counted locally, and then they're scanned at a number of central locations, and basically they're all tallied centrally, and they're posted from, should say, 9 p.m. So at 9 p.m. in the evening, they start posting them, they count throughout the night, and then they recount. They do that even without the courts. They recount from the beginning just to make sure. And in the end, sort of that's the general idea. And now I have a bonus slide, so I'm skipping that. Now, the reason we're here, of course, is they have an election administration system. It does things live, which is things like whenever somebody walks into a location and tries to cast their vote, it checks who they are, and then it ticks them off. It doesn't do that for all of Norway, but it does it for all the large places in Norway. The smaller ones still use paper. And then there is a bunch of batch processing, which means they scan the ballots and they go into the system. And there's an output like who's winning the election, right? It's supposed to give that. Now this application is a locally developed application. It's originally something from somebody else that they took over, and then they've been working on it for a few years. It is a wildfly clusters for a number of different things. There's one for scanning, one for backends, one for administration, things like that. Almost entirely using Hibernate. It's all backed by a single Postgres cluster. It's a Postgres 9.3 on Red Hat running on bare metal hardware. This is the reason why I'm late. They wanted somebody to babysit it, okay. From a Postgres perspective, it's a fairly simple system. They got 3 data centers, 2 local data centers in Oslo, in different locations in Oslo, and a third really big trouble data center that's far away, just in case something goes really bad. Use Postgres streaming replication in between them. Deal thing here, everybody's worried about performance, right? Because this is a new database, they didn't know it all, put Postgres in, did it work? Yeah, it kind of did. Got about 15 to 20% of load most of the time. All the bottlenecks were elsewhere, like in 3G modems that were incorrectly configured, NAT tables that weren't big enough, things like that. There were 2 things that actually happened on Postgres. Unfortunately, I'm not getting to those because I ran out of time.
All done, thank
For
you.
those of you who are interested, they're on my Twitter.
All right, so a very unimaginative title for this talk, but better constraints and really more thoughts on natural keys and how to do constraints. I can't see this on the screen here, so I'm just going to move forward.
You need to talk louder then.
Or turn this. So yeah, I started with Rails back in 2006. That was actually the 1.14 days. Now we're at like 4 something. And yeah, that means MySQL, those other databases that Mike just talked about. And back in those days, Rails people didn't do foreign keys. They still only do surrogate keys. And app-level uniqueness constraints, that results in a lot of bad data. It's not fun. That's my background. This talk was inspired by talking to Josh Berkus at PGConf 2015, and he did his lightning talk, Stop Circuit Key Abuse. But this isn't strictly about natural and surrogate keys. It kind of plays off of some of the ideas in a conversation after that. So we have a problem in this table. There's bad data, and there's actually 2 different types of bad data. We're only going to talk about one. The first is that there's some obvious duplication on ID 1 and ID 3. Yes, I know they're not the same case, but they're really the same name. And then row 5 is someone just can't type, and that's another problem, but we won't solve that today. There are other schema issues here at play, at least on the production database that I'm working on. That client ID in that column right there, each of these records, a real person could be associated with multiple clients for various reasons. That makes the problem even worse because we want to store preferences on those rows and we can't keep them for the right person. But we're only going to focus on the one part. The big idea here is that reality isn't always reality. And so talking to Josh, I realized that, so yes, it's true that each one of you can be linked to multiple organizations, or you could have multiple employers, like you have 2 part-time jobs or something. But if we don't know how to distinguish you from the other person, if there are 2 different people with the name Josh or Magnus or whatever, if we don't know how to distinguish you, there's no more information, then it doesn't really matter in your application. So this leads me to that question: do you actually have the operational information necessary to match the real world? So in the system that I'm working in, people are taking phone calls and booking rides for passengers, and a lot of times they only get a name and maybe only a first name, and that might be all they know, other than the fact that it's for a specific customer or corporation. So we don't necessarily know exactly who this is, and that's just a reality that we're not going to be able to change at the system level. So how do we make this a bit more distinct so that we at least don't have duplicates? And so I want to propose a mad scientist mix of arrays, triggers, and exclusion constraints. First, for some of you who don't know, exclusion constraints are basically a generalized unique. I can set up any number of columns that can't be equivalent to any other column, and equivalent there just means that we have to have these operations that apply. They don't have to be equals, et cetera. For example, with arrays, you can do overlaps if you've added a plugin or extension that gives you B-tree ops for gist indexes. So I have this new schema, kind of simplified down, and I have basically a name. As an aside, Josh would tell you that this name is not an atom, and I will disagree with Josh, but it depends on if you have a legal requirement for first and last name or not. And an array of organization IDs. And then I have this join table from my people table to an organizations table that you don't see here. We're not going to talk about the triggers today, but there's really just 2 constraints here that I want to have. First is a unique index that is conditional, only applies if we have an empty array, because an array over an array doesn't overlap if they're both empty. So just kind of a thing that you can have happen. And then this exclusion constraint that basically says we can't have any row equal another row where the lower of the name is equivalent, and then the organization IDs overlap. By the way, this also takes advantage of function indexes. I'm not showing the triggers here, but basically they just guarantee that person organizations get synced, those IDs get synced into that org IDs array. So basically, when you want to have real, actual, distinct data, unique data, and not have people entering duplicates, sometimes you have to change your assumptions about what the real world is versus what your system reality is, your functional reality is. That's different than reality. So anything more about me there?
Okay, thank you. My name is Peter Gagan. I work for Heroku, and this is about sorting improvements in Postgres 9.5 and 9.6. Okay. So, as I think we all know, sorting is an important operation. It's of fundamental importance, being a major supporting operation for things like create index, order by, etc. I think everyone here is probably aware of that. So firstly, I want to speak about the 9.5 work, which was basically this thing called abbreviated keys, an internal optimization, which I feel is noteworthy enough to talk about here. This applies to the only particular types for 9.5, that was text and numeric. So internally, this whole sorting thing works by, we use a conventional sorting algorithm such as quicksort, sort an array of fixed size structs that consist of 8 bytes, which is used to store the first column in the tuple that is being sorted. So if it's ordered by ABC, it would be A, just for example. And this is, so we have that, and we also have the tuple proper, as we call it, which is the rest of it, the entirety. And in fact, the thing you're actually sorting, an index tuple, for example, something like that. And so this is always something that's sped up, passed by value types, such as integer, because that 8 bytes in that field represent the leading attribute, the leading column, could be consulted directly without doing pointer chasing as comparisons were performed in, say, a quicksort. So the problem was historically with a lot of types, including text and numeric, they often wouldn't be able to fit in 8 bytes. So that would actually just be a pointer, and we'd have to do pointer chasing in order to do comparisons even just for the leading column, which will typically resolve most comparisons. My approach was to just take the first 8 bytes of the string in the case of text and compare that, and if necessary, I could do a tiebreaker to get the authoritative comparison. In the authoritative is it less than, greater than, or equal to value from the tuple proper. But in most cases, it'll be sufficient to just look at the leading attribute stored directly in these sort tuple things. Anyway, this can make great index on text easily 3 times faster. In New York, earlier in this year, a guy called Corey Huenker, who does a lot of stuff with data warehousing, he had a complaint about it, and I asked him to try it out. And for him, his problematic create index was 10 times faster, which was text as well. So there's also a special encoding thing we do for numeric. So numeric benefits even to a greater degree often. So this is not just incremental progress, but could be considered somewhat of enough of an improvement that it can enable things that you couldn't do before. So it's not simply incremental progress, because it's big enough of a change that, suddenly Postgres 9.5 or Postgres in general is a much more credible system for data warehousing. Now I'm following this up in 9.6. I'm addressing external sorting. I've been doing this in the last 3 months. I'm replacing the algorithm used for external sorting I'm replacing it with more extensive use of quicksort for runs that are sufficient to fit in memory, but when we don't have enough memory to perform the sort entirely in memory, we must go to disk. Basically what I'm doing in all cases, including the 9.6 stuff, is optimizing for the memory hierarchy, making good use of CPU caches, and making sure that as long as something is in L1 cache, we do as much work as we can, as long as we have it there. So all of this is essentially concerns exploiting temporal and spatial locality, which is more and more important on contemporary hardware. So for create index on integer columns, this is 2 to 3 times faster, even if you have way less memory than you would require to do conventional internal sort, assuming you've got sufficient sequential I/O bandwidth. So again, I think pretty significant piece of work. Okay. Oh, okay. Is that that's it? I'm done.
All right, so Test Factory, production of test data for fun and profit. There's one thing that I think that we can all agree on. It is that writing unit tests is awesome. Or not. For those of you that don't do unit testing, shame on you. You really should, because I'll tell you, once you can change your code and not worry about getting a call at 3 in the morning, it's awesome. But, you know, writing unit tests is extra work. It's work that's well worth doing, as opposed to marshaling test data, which is extra work that sucks. Until now. Enter Test Factory. Test Factory makes it easy to manage, create, and retrieve test data for your unit test fun and pleasure. First, you register data. Here we say, hey, we need a customer, a simple test customer. We insert into our customer table. We return the data back to the test framework. Then when we need to see our test customer, hey, look, select from TF get. Ignore the null thing. It's a oddity. And simple test customer, there's our data. It's so simple. That's it. We're done. It's posted to PGXN if you Google for that. Or there's the first link there is a blog post that explains it in slightly more detail than I just did. Thank you.
Hi, my name's Steve Randall. I am the database guy at a 10-person company. We do software as a service for stock market analytics for many large clients. Talking about dependencies within Postgres and how to determine them. pgdepend can provide some of the dependencies, but it doesn't show them all, especially within your functions. So let's say you've created a table called client data temp for a specific customer custom request. 2 years later, you're looking and saying, what the heck is this for? And you don't know. So you go through and you say, you look through your code and no, you can't find it. So you invoke pgdepend and it doesn't know. And so you drop the table. It happens. And so the next morning, the client calls and says, where's my FTP report? And that's when you remember why you had that table. So I've written find dependencies. And really all it does is it goes through the system catalogs. It builds a list of all the objects that might be used in a function, a table, a view, a materialized view, a foreign table, used in other functions. And then it scans through the information schema routines table for uses of that. Because it's doing text string searches, and I've got the main ones right there, in wildcards there are some formatting rules that have to be adhered to for this to find them. Over the past 4 years, I've written 90% of our production code, so it's easy for me to adhere to my rules. And I know that all code is self-documenting, but I do have it as a to-do list to actually write a document on the formatting that has to be there. So once you run through it, you can now select and what it comes out with, and because I had to convert this to PDF at the last minute this morning, the formatting on this is off. But you get an object name, what that object type is, what it depends on, and what the depends on type is. So on this first one, there's a function called getPennies that is looking for a symbol list external, which is a foreign table. So part of this relies on a dependency function I found on Stack Exchange written by Clin, and if this Clin person is around, I will want to buy him a free beer later because it made using pgdepend so much easier. So in the case of my theoretical table that I would drop, I can now run this saying that, where it depends on client data temp, and I find out that, well, the daily FTP report and the monthly FTP report depend on it. So yeah, I wouldn't have dropped it. In an example that actually happened this week, I had a table that was getting large, performance was slowing down. We keep a year's worth of data online usually. And I looked and I said, well, who's actually using this table? And I found out that we only needed to keep a quarter of a year online for this particular table, not a full year. I was able to drop 70 million rows. Performance got much better after that. Yeah, so that was work. That was worth it. Anyhow, it is out on GitHub, under there. Go! That was last year. That was Chicago. That's the address. I can be reached by email for that. I put this together rather quickly. It's been sitting out there. It's languished a little bit. I haven't gone through. There's a lot of improvements that can be made to it, and any suggestions, any enhancements, additions would be greatly appreciated. Thanks.